Welcome back to All This Math. This is Professor Parker. Make sure you subscribe to the All This Math YouTube channel. Make sure you like this video. Make sure you drop a comment down below, especially after I get to explaining. If there's something that you don't understand, don't be shy. Drop a comment in the comments. Drop your question in the comment section. I'll answer it as soon as possible. I may even do a follow-up video to specifically explain better the answer to your specific question. All right. And also, last but not least, share the video with somebody else. Put it into the group chat. Do whatever. If you're a parent, especially watching this, put it in the group chat. Tell some other people. All right. Tell your child's teacher about this channel. Tell your child's teacher about this channel. All right. Ask your child to put the channel in the Google Classroom if your school uses that. Put it on Class Dojo, whatever. All right. Now let's get into this. Let's read it and make sure we understand what we're being asked to do. It says to order the numbers from least to greatest. From least to greatest, not greatest to least, least to greatest. And then we have 1, 2, 3, 4 numbers here. We have 2 and 2/5. That's a mixed number. Why is it called a mixed number? Because it includes a mixture of two types of numbers. You have a whole number and a fraction. A whole number and a fraction. Two types of numbers combined into one number. Whole number, fraction. That's why it's called a mixed number. 11/5. What do we know about this? This is what we call an improper fraction. Why? What makes it improper though? The numerator is larger than the denominator. The numerator 11 is larger than the denominator 5. Then we got another mixed number, 2 and 3/10. Then we got another improper fraction, 31/10. Now, there are multiple ways to answer this question, but this is how I would do it. This is how I would do it. How I would do it is, I would say, all right, I'm going to convert everything to a fraction, right? So these two are already fractions, right? So I don't got to convert them, right? But these two are mixed numbers. So I'm going to convert these into fractions. And then check this out. In order to compare the fractions, though, I need for my denominators to all be the same, right? That's one way to do it. You don't got to do it that way, but that's how I'm doing it. That's my twist. That's my flow, right? I like or at least today, this is what I feel like doing right now, right? Making sure my denominators are all the same, all common. And then all I got to do is just compare the numerators, right? I go least to greatest with the numerators, right? So look, step 1, convert the mixed numbers into fractions. So everybody watching this video, if you don't already, you about to learn how to convert mixed numbers into fractions. Now, a mixed number, when it's converted to a fraction, is going to be an improper fraction, right? By definition. All right. So this is what we're going to do. We're going to say 2 and 2/5. 2 and 2/5 is going to turn into what? 2 times 5, which is 10. 10 plus 2 is 12. 12 is going to be our numerator. I'm going to do it again. You take the whole number. It's like a quick little algorithm. Take the whole number, multiply by the denominator. That's 2 times 5. That's 10. Take that 10, right? Add it to the numerator. That's 2. 10 plus 2 is 12. Then you keep the denominator, 5. So this is the same thing as 12/5. How many fifths? 12/5. How many fifths? 12/5. 2 and 2/5 is the same thing as 12/5. Because think about it. Check this out. I like for math to make sense. So let me further elaborate so that it makes sense. How many 5s or groups of 5 can fit into 12? One group is 5, 2 groups is 10, 3 groups is 15. That's too much. You got to chill. You can't fit 3 groups of 5 in the 12 because that's going to be 15. That's too much. See, that's why it should make sense. Make sure the math makes sense, right? Teachers, if you're watching this, make sure you explain stuff in a way that it makes sense. You got to go beyond the textbook. You got to go beyond what the curriculum might give you because the curriculum might not actually make sense, right? At least not to your students, right? Maybe not even to you, all right? So how many groups of 5 can fit into 12? 2 whole groups of 5. But if 2 whole groups of 5 makes 10, and we try to get to 12, what's left over? The difference between 12 and 10. 12 minus 10 is 2, right? So that's where we get the 2/5 from, right? The whole 2 comes from this many groups of 5 can fit in the 12. 5 times 2 is 10. And then you say, okay, the difference between 12 and 10 is 2. So that's how many parts of 5 can also fit into 12. 2 parts out of 5. If you break 5 down into 5 equal parts, 2 of them. 2 of them can also fit into 12. The other 3 can't fit. The other 3 can't fit. That's why we're dealing with 2/5. That's where the 2/5 comes from. All right. So that's why 2/5 and 12/5 are equivalent. All right. Now, 11/5 was already a fraction. Over here, 2 and 3 tenths. We're going to do the same thing. The same algorithm. I just like shading in the arrowheads. Don't pay me no mind. Take the whole number, multiply by the denominator. That's 2 times 10. 2 times 10 is 20. Take that 20, that product 20, add it to the 3. What's the sum? What's the sum of 20 plus 3? That's 23. And then you keep the same denominator. You already had 10 for your denominator. You keep that. Now you got 23 tenths. All right, you got 23 tenths. So 2 and 3 tenths is equivalent to 23 tenths. Wow, let's make it make sense. How many groups of 10 can fit into 23? One group is 10. Two groups is 20. Three groups is 30. That's too much. You got to chill. 3 groups of 10 can't fit into 23 because it's only 23 there. So 2 groups of 10 can fit. That's where this 2 came from. That's where this 2 came from. Now, but what's the difference between 2 groups of 10 is 20? What's the difference between 23 and 20? 3. So if 10 is broken down into 10 equal parts, 3 of those parts can also fit into 23. 3 of them. 4 can't fit because that would put you at 24. 5 parts can't fit. That will put you at 25. 6 parts can't fit. That will put you at 26. So you only include how many parts that can fit in 23. That's why 23 tenths is equivalent to 2 and 3 tenths. Where does the 2 come from again? How many groups of 10 can fit into 23? 2 groups, because 10 times 2 is 20. 3 groups can't fit. That's why this is not a 3, because 10 times 3 is 30. 30 is more than 23, right? Now, we got everything in fraction form. Now, what did I say my next step was going to be? I already told y'all. I told y'all from the rip. We need common denominators. We got 5s, and we got 10s and 10s. All right? So now this is what we got to do. We need to know what's the smallest number. This is how you find a common denominator in any problem. What's the smallest number that 5 and 10 can multiply into? What's the smallest number, right? Not just, now some teachers will tell you to do this. They'll tell you to just multiply the denominators together. That's cool, but I think sometimes that's a little intellectually lazy. That's what I call that. You know what I'm saying? In some situations. And it also creates more work. You think you saving yourself from work, but you actually create more work because you create a larger fraction unnecessarily. When you could have just did the work up front and just thought to yourself, yo, what's the smallest number that 5 and 10 can both multiply into? Both of them. It's going to be 10. You know why it's going to be 10? Because what's 5 times 2? 10. What's 10 times 1? 10. 10 is the smallest number that 5 and 10 can both multiply into. They both multiply into 10. So now, if 10 is going to be the LCD, that means these two fractions ain't changing. They already got 10 for a denominator. They cool. But these two got to change. All right? So now that means that 12 fifths is going to change into 24 tenths. Now, why? Why though? Why it's going to be 24 tenths? See, I'm not one of them teachers. A lot of teachers would just write this on the board and be like, oh, it's 24 tenths. And they keep it moving. No, tell me why. Why is it 24 tenths? I'm going to tell you why. Because in order to make 5 become 10, we got to do 5 times 2. And whatever you do on down the bottom, you got to do up top. Right? So if we do 5 times 2, that makes that a 10. Then you also got to do 12 times 2. What's 12 times 2? Make sure you know your multiplication facts. That's going to be 24. So 12 fifths is equivalent to 24 tenths. That's where we get the 24 tenths from, right? And we're going to do the same thing with 11 fifths. 11 fifths, common denominator is 10. What's the 11 going to turn into? The 11 is going to turn into a 22. 22 tenths, right? Because what's 5 times 2? That's how we got the 10, our common denominator. But if you do that down bottom, you got to do this up top. Whatever you do down, when you're dealing with common denominators and trying to find equivalent fractions, whatever you do down the bottom is what you're going to do up top. Whatever you do down the bottom is what you're going to do up top. 5 times 2 is 10. 11 times 2, 22. Now we straight. Now our denominators is all the same. Denominators is all the same. So now you got to do is look at the numerators. So I'm like, okay, how many tenths do I have? How many tenths do I have? How many tenths do I have? Right here, I got 24. Here, I got 22. Here, I got 23. Here, I got 31. We supposed to go from least to greatest. What's the smallest number? Smallest number, boom. This one right here, 22. 22 tenths, right? So we're going to start with 11 tenths. No, I'm tripping. Hold up. I ain't mean to write that. This 22 tenths, 22 is the smallest numerator. You start with the smallest numerator, 22 tenths. Now, originally, what fraction was that? 11 fifths. So that's our first. Now, what's the next biggest numerator? 23. 23. What was this initially? 2 and 3 tenths. You gotta give the answer in the original form. The original form. The original form. How the problem was originally written. Right? Not based on the equivalent fractions or improper fractions that we created, right? All right. Then we got 2 and 3 tenths. Now, we did 22, 23. What's the next? 24. 24 tenths. What was that originally? 2 and 2 fifths. 2 and 2 fifths. Last but not least, we got 31 tenths. So that's least to greatest. Now, this is not the only way to do this. It's just a way I particularly decided to do it today. Right? I might go back and watch this video tomorrow or a month from now, or whatever, and be like, yo, I could have just did it that way too. And I might do another video. I might run it back, do another video using a different method. Right? That's another thing I love about math. There's so many different options, so many different ways to do these problems. So many different ways. You see what I'm saying? All right. So we got 1, 2, 3, 4. We got 4. We got our 4 numbers, and look what we did. Let's do a recap. We looked at all 4 of our numbers. We converted everything into fraction form, right? That's how I chose to do it. We converted everything into fractional form, right? Then we found common denominators, right? We found equivalent fractions and made sure we had common denominators for everything. That was step 2. Then the step 3 was we compared the numerators, right? Whatever was the smallest, we went from least to greatest in terms of the numerators. We went from least to greatest in terms of the numerators. That's all we did. All right. And that's it. So now make sure you subscribe to the channel if you didn't already. If you still got a question about this, that's cool. Don't be embarrassed. It's cool, right? Especially if you're saying this for the first time. I know I went over a lot, right? Drop your question in the comments, right? So I'll know. That's how I'll know. I'll make another video for you. Like real talk, I'll make another video for you, right? Just based on your question, right? Drop your question in the comments, right? Also share the video and like the video. All right. I'll see y'all later. Peace.